So this lecture is about powers or properties of exponents, and the purpose of this lesson is to teach you how to simplify your answer. Now, for pages 38 and 39 in your packet, which you're going to be doing the odd numbers of, you need to make sure that your answer only contains positive exponents. Okay? So whatever you do, whether your answer is the denominator of a fraction or the numerator of a fraction, make sure that your answer is positive. Your exponents are positive. Okay. So I'm going to go over a couple of different rules. The first one is, what do you do when you multiply exponents? Go ahead and copy down this example. 2m squared times 2m cubed. Now, 2m squared is the same thing as saying 2 times m times n. And if you're multiplying on this 2m cubed, you're also multiplying on 2 times m times m times m. What you can do is you can actually multiply the numbers by themselves. So 2 times 2 is 4. And then since we have 1, 2, 3, 4, 5 m's, we get 4m to the 5th power. So basically the general rule is to take the two exponents that you see and add them together. So 2 plus 3 equals 5, which is the same thing that we got right here, and that's the shortcut. So the trick is when you have the same base to add the exponents when you multiply. Alright, now I'm going to move on to what happens when you divide exponents. Go ahead and copy this problem down in your notes. We have r squared divided by 2r cubed. Now if I were to write this problem out, it would be r times r over 2 times r times r times r. And we know that when we have one thing on top of a fraction and one thing on the bottom, that they cancel out. So these two r's cancel out right here. And since we have nothing left on the top, the invisible number is actually 1. So we have 1 times 2r, and that's left. And that's our answer. Now, remember, we learned earlier this week that this is the same thing. If we see an exponent with 1 over something, it's the same thing as saying r to the negative 1. So another way to write this answer would be 1 over 2, well, r to the negative 1 over 2. And I just wanted to write it like this to prove a point. We have 2 on top divided by 3, and when you divide exponents, you actually subtract. So 2 minus 3 gives me negative 1, which is why my exponent right here is negative 1. But for this packet and these pages, remember your answer needs to be positive exponents, so our actual final answer is 1 over 2r. So the trick to dividing exponents is that you subtract the exponents when you have the same base. Only when you have the same base. And since we had r here and we had r here, we were allowed to subtract the exponents. Okay. Now, what happens when you have negative exponents? What do you do? And we've kind of already talked about this, but I'm going to go over it again. Go ahead and copy down this problem. We have 4n to the 4th times 2n to the negative 3. So I'm going to keep 4 times n to the 4th the way it is, since it's a positive exponent. But since we have n to the negative 3, the negative 3 is actually saying that it's 1 over n to the 3rd. So whenever you see this negative exponent, it's 1 over that. So to write 2n to the negative 3, I'm going to write 2 over n to the third. Okay, now I'm going to write this all out. You can do the shortcut, which I'll go over in just a little bit, but it's like this. 4 times n times n times n times n times 2. Remember, since this is actually a fraction, you can multiply across the top and then you multiply across the bottom. So we get 1 times n to the third, which is the same thing as saying n times n times n. Since we have n's on top of each other, we can go ahead and cancel out. And what I'm left with is 4 times n times 2. And 4 times 2 is 8. And then we have n left, and that's actually my final answer. Remember, if you wanted to do the shortcut though, you could have taken the exponent on the top and the exponent on the bottom, subtracted them, and gotten 4n to the first power times 2 over 1, which is the same thing as saying 8 over n. Now what happens if we see a negative exponent on the outside of parentheses? Well, it just means that this negative exponent affects everything that's inside the parentheses. So another way to write this would be 1 over parentheses 2x squared to the fourth. And I'm going to go ahead and simplify this even further. So this is also like saying 2x squared times 2x squared times 2x squared times 2x squared. Oops, that's a square, not a 4. And you do it 4 times because there's the 4 on the exponent. Okay? So now I'm going to further simplify this. So 2 times 2 times 2 times 2 is actually 16. X squared times x squared times x squared times x squared. I could write it all out, but I know the shortcut is to add the exponents. So 2 plus 2 plus 2 plus 2 gives me 8. And that is my final simplified answer. Alright. Now, we're going to go over 2 more rules. Rule number 4. What happens if your exponent is 0? Well, this one's really simple. Anytime you see a number or an expression that's set to the exponent of 0, it's always going to equal 1. So since this whole parentheses right here is set to the exponent of 0, this is simply 1. Okay? Now what happens if only part of the expression has the exponent of 0? Well, this part right here, whatever is attached to this exponent, becomes the 1. And then this parentheses actually becomes 4 times 1 to the fourth. So 4 times 1 is 4 to the fourth. And so this is the same thing as saying 4 times 4 times 4 times 4, which gives me 256. And that is my final answer. Okay, one more rule. What happens when you have different bases? Well, if you have different bases, then you can't actually combine the exponents together. You simply write the different bases together. So go ahead and copy down this example. 4v cubed times vu squared. And I'm going to go ahead and write out what this means. So we have 4v squared, or v cubed, excuse me. So it's like saying 4 times v times v times v. And the vu squared is the same thing as saying times v times u times u. And I'm going to go ahead. This 4 can't be multiplied by anything else, so I'm going to go ahead and write it down again. There are 4 v's being multiplied together, so v to the 4th. And since there are 2 u's being multiplied together, I'm going to do u squared. And I can't combine v and u because they're different bases, so I have to just leave my answer the way it is. Again, you could have used a shortcut to simplify this. We have 4v cubed times v u squared. Again, I noticed that 4 can't be multiplied by any other number, so I'm going to write it down right here. But I noticed that there are 3 v's here, and there's, technically 1 v right there. So I'm going to go ahead and add 3 plus 1. That's a plus sign. It's kind of hard to read, but okay. V to the 4th. And since u can't be added onto any other similar bases, I'm just going to leave it as it is and get u squared. And again, I get the same answer as I did using that method. And that's it. So go ahead and do the odd numbers on page 38.